I wanted to share how to do an ANOVA using Excel and the TI calculator. Let me share my screen real quick here. So here's a problem. It says, is a statistics class delivery type a factor in how well students do on the final exam? So that's the question we're addressing. So we have three groups. The table below shows the average percent on final exams from several randomly selected classes that use the different delivery types. So we have face-to-face class, a hybrid, which would be a mix of online and face-to-face content, and the online classes. We're going to assume that all of the distributions are normally distributed, that the population variances are equal, and the groups are independent of one another. We're using alpha of 0.10, so that's our significance level. When we're talking about three or more groups here, we're talking about an average, so we're going to use the ANOVA process. And the hypotheses are already written here. Our null hypothesis is that the three means are equal to one another, so that the average test score would be equal among them. We would expect differences in the sample means, but is there enough difference in those sample means to conclude that the population means are unequal? Now, it could be any one of those means are unequal to one another, so we write out the hypotheses at least one mean is different from the others. It could be all three are unequal. Maybe face-to-face and online are equal, but not the hybrid. Or maybe the face-to-face and hybrid are equal, but not the online. There's many different combinations of ways that you can have unequal here. So rather than writing out all the combinations, we just say at least one mean is different. Now we need to find the test statistic. And a lot of questions will even set up a blank ANOVA table for you to fill out to find that test statistic. We're going to use technology to find that very quickly for us. So I'm going to copy my data. You can also just type it in, but I'm going to copy, do Control-C, highlight it, copy it in here to Excel. If you're not getting a nice column of values, another trick that you can do when you copy is if you right-click in a cell, on a PC at least, and then do Paste Special, and then do Unicode text, that'll strip the formatting out of there. So sometimes that's nicer to use than, you can see all the formats that come over from the question there. All right, so we have our data. Don't worry about these blanks down here. Excel will handle those just fine. I'm going to go to the Data tab under Data Analysis. If you don't have the Data Analysis tool installed, you can watch and search for a video on how to install that Data Analysis tool. So the Data Analysis tool has a built-in ANOVA. There's different types here. We're just working with what we call the single factor. So we have delivery method as our factor. It's split into three different levels, but there's only one factor there. So we're going to do ANOVA single factor, click OK. And then I can clear all that out and show you how I got to that. I was fooling around with this earlier, so I had those filled in before. So let me clear those out. So the input range, take your mouse, highlight the face-to-face value. Make sure, so notice I'm including those blank numbers, those blank cells, and that's okay as long as I make sure I get all of the numbers within my box here of my input range. Oh, I was in the wrong cell. I don't know if you noticed that. I was in the output range. I want to be in the input range. So let me select that again. Here's my input range going from cell A1 to C10. Don't, again, worry about those blanks. I did highlight the label in the input range, so I want to make sure I check the box for labels in first row. Don't check that box if you have A2 to C10 here, if you didn't select the labels in the input range. Type in your alpha from your problem, 0.10. Output range, you can do either a new worksheet, that would form a worksheet down here. I'm going to do the output range and have it appear in the same place as what I'm starting with. So I'm going to select inside the little box for my output range and then use my mouse to select one cell where I want my output to start. It's going to be below and to the right of that, so make sure you have room over here that you don't overwrite any of your existing data. Click OK. And not only do you get the ANOVA table, but you also get our descriptive statistics for each of the groups here. Make those columns wide enough so you can see it all and move over here. So we have the sample size for each group, the sum if you were to add up all of those groups. So if you were, for instance, trying to do this work by hand and verify it, you could find the overall sample mean, the grand mean, by adding up all of these values and totaling it by the total of the count. Like we have a total of 24 values, so just add up 9 plus 8 plus 7. And if I sum up, copy that over, sum up 646, 576, and 591, these three numbers, our total sum is 1,813. So I could get a grand mean by taking 1,813 divided by 24. That's only if you were showing your work by hand. Then we have the sample mean for each group. We would expect differences always in those sample means, but how far away do we need to get to say that they're statistically significant? Our sample size is pretty small, so we need to have a pretty big difference in our sample means to show overall that there's a difference in the population means. And that's what the ANOVA does. It does an omnibus test, testing everything at once to see if there's a difference in those averages, but it doesn't tell us exactly where those differences lay. So our variance would be the sample variance for each group. And then we have our ANOVA table down here at the bottom. Between groups, sometimes it's called treatment and sometimes it's called factor, depending on other software or textbooks that you're using. Within groups, sometimes it's called error, so it just depends again on what your textbook uses or your technology uses. And then we have our sums of squares, our degrees of freedom, and our mean squares. Just as a check for yourself, the degrees of freedom are the number of categories minus 1. We had 3 groups, so 2 degrees of freedom. The within groups or error is the total n, the 24, minus the number of groups, which is 23. And then the total degrees of freedom is 23 here. The mean square is taking each sum of square divided by its degrees of freedom. And this test statistic is taking the mean square between groups divided by the mean square within groups. That's how you get the 4.108. In fact, we could just verify that real quick. If I do equals and then select the 390 and then divide by our 95 here, we have 4.108 that matches our test statistic. Excel also gives a p-value and a critical value. So the critical value, really quick for an ANOVA, you're always doing a right tilt F test. The F distribution starts at 0, it's skewed to the right. So the shaded tail would start at 2.574 for your rejection area. 4.1 is out in that tail, so you would reject the null. Or we can compare our p-value with alpha. P-value is less than 10%, which alpha was stated in this problem. So if your p-value is less than or equal to alpha, you would reject the null hypothesis as well. So let's get back to the question. In here, they were asking for the test statistic and the p-value. So I can, once I find this, just copy. So I'm just going to Control-C and copy that back to my question here, paste it in. Show your answer to 3 decimal places, so you could round accordingly. In this system, you can go out more decimal places than what they ask for, but you always want to be careful with your rounding. The p-value, so I can select this number and put in my p-value. And again, if you go to 4 decimal places, that would have been there. Just look at that 5th number, make sure it's not 5 or above to round accordingly. The p-value is less than or equal to alpha. So based on this, we would reject the null hypothesis. If you reject the null, then there is a difference. So somehow the delivery method made a difference. So there is sufficient evidence to support the claim that course delivery type is a factor in final exam score. Now that's not telling you where, like which one is the best method then. We'd have to do some type of post hoc test, Bonferroni, Chaffee, Tukey, Fisher. There's all sorts of different types of post hoc tests. So look at your textbook and what your instructor wants you to do that post hoc test to see where the differences are. Now, how do you do that on the TI-84 calculator? Very quickly. So you could either type the data into different lists when you're going through. I have those in here, so let me turn my calculator on. So I had already preloaded those, but let me show you a quick trick. So I'm going to clear that out. Just clear my list 3. So you can see where I got those. So I could type them in, especially on a handheld calculator. But if you have an on-screen emulator like I have here going, so I have list 1 is my face-to-face data, and list 2 was my hybrid data, and list 3 I want my online data. So I can actually copy from Excel. It doesn't work well from other systems. So if I tried to copy directly from the problem in here, it probably wouldn't copy over nicely. So if you copy this to Excel or Google Sheets and then copy that over to your calculator, it works a lot better. So I'm going to copy it, do Control-C, go over here to my editor, Control-V for paste. It automatically pastes all of that data in there without having to type it. So that's just a nice fast way to get large data sets into the calculator. Maybe just want to verify your answer. from what Excel is, or maybe you don't have the data analysis tool. So in our calculator, after you enter your data into your list, you have to remember what list names that we're using, list 1, 2, and 3. We're going to go to Stat. Then we're going to go over to Tests. And it's at the very bottom, so I'm going to just up arrow once, but you can also just scroll all the way down to the bottom for the ANOVA. And then you have to tell it what list your data are in. So I'm going to do second L1. Notice the list name right above the 1. And then a comma. And then second number 2 for list 2, comma, and then list 3. If you had 4 groups, you'd have a list 4, or 5 groups, list 5. Just keep going. But we only have 3 groups. So end at list 3 and hit enter. Here's your test statistic that matches the 4.108. Your p-value does not give a critical value, so you're stuck using inverse F distribution. Depending on your calculator, you probably don't have that. Might have to have a program to run that or use Excel to find that critical value. Factor is the same thing as between groups. So here's our sum of squares and mean square for between groups. If I arrow down here, error is the same as within groups. And then the last number we don't use very often, but some post-hoc tests will want the square root of the mean square for within groups. So if I took the square root of 95.01, I get 9.747. All right, that is how you do ANOVA using Excel and a TI calculator.